All right, we're going to talk about in section 6.3, we're going to talk about something called synthetic division of polynomials. This is a shortcut way for what I showed you in class for dividing polynomials by a binomial. I believe synthetic division will be easier than what we were doing with long division, but if you've got questions and you don't understand this video, please ask me during class. As I just said, this is a shortcut way for dividing polynomials, but the key is you got to divide by a binomial, and the binomial has to be in the form x minus a. It needs to be linear. It's got to be a linear binomial. Otherwise, this method doesn't work. And the key is it's minus a, which I'm going to talk about in just a second. That means the a value that we're going to use will be opposite sign, but you'll see that in just a second. Second, you only use the coefficients to do this method. We don't use any powers, we don't use any variables or letters, just coefficients. Third, it must be written in standard form. And fourth, every power of x has to be accounted for and represented by a coefficient. What I'm saying by that is this. If a term is missing, we must use 0 as a placeholder. And I kind of mentioned this the last video when we talked about multiplying. It is very important if a term is missing that you put 0 in its place. And I'm going to do an example of that right off the bat. All right. So we're going to divide x to the fourth minus 2x to the third plus 3x plus 1. We're going to divide it by the linear binomial x minus 3. Oop. Trying to get rid of that line there. Now, in order to do this, the 3 steps, we first must write the coefficients, including zeros, in standard form. Well, you're going to notice we're missing the x squared term. So that's like having plus 0x squared in here. We need to account for that. Okay, so that's what I talk about when I say include zeros. So I'm going to take my polynomial, and all I'm going to do is, in order, I'm going to write the coefficients. 1, and then negative 2, and then 0 as my placeholder for x squared, and then the 3, and then the 1. So I've accounted for all my coefficients. I've omitted all the variables and exponents, which says in Rule 2 over here. And then remember, step 3, your divisor is opposite sign. Now, the prior slide said our divisor, which is going to be a, it's in the form x minus a. Okay, which it is. It's x minus, so then right there is our a value, which is what we're going to use as our divisor. And you always put your divisor in a little box like that. Now, very simply, in order to do synthetic division, you just draw a line, leave one blank row. And here's how synthetic division works. You always drop down the first term. So the first number comes down. We multiply what's in the box times that number and put it under the next coefficient. So 3 times 1 is 3. And so I put 3 there. And then we add the coefficients. So negative 2 plus 3 is 1. And then we repeat the procedure. We take the divisor times that number, 3 times 1, and put it up here again, which is 3, under the next number. And then we add the numbers together. 0 plus 3 is 3. And then I take 3 times 3 again, which is 9. And I add those two together and get 12. And then the last step is to add or to multiply the 3 times the 12, and I get 36, and I add them together and I get 37. And you've already done your division. You've done this particular problem. Now all you have to know is how to write the answer. The key is the coefficients of your answer. are 1 less power of x than what it was previously. So what I'm circling, my coefficients right here, I started out with an x to the 4th, so therefore my coefficients of my answer, this would be 1x to the 3rd, 1 power less. And this coefficient would be plus 1x squared. And this coefficient would be plus 3x. And this coefficient is your constant, plus 12. Now, the final number, which I'm going to put in a box, that's your remainder. You guys have all done division problems in the past where you have a remainder. So, the answer to my problem that I started with and I circled in green is in the green box with a remainder equal to 37. And you must write all of that as part of the final answer. And that is how you do synthetic division. Now, I want you to practice. We're going to do a couple problems together. So first of all, if you want to pause the video and do it on your own, go ahead. Otherwise, I'm going to lead you through it very slowly. I look at this particular problem, and I notice the x squared term is missing, so I need a 0. So therefore, my coefficients are 1, 0, negative 57, and positive 56. Now I find my a value. Well, I notice it's in the form x minus, so that's good. So that number 7 is just my a value. So that's what goes in the little box on the left side of the problem. I'm going to put a as 7. I'm going to draw my line, and I'm going to bring down my first number, which is 1. And again, I'm going to times. I multiply those two numbers. 7 times 1 is 7. I put it under the next number, and then I add. So which I get 7. And now 7 times 7 is 49. And then I add. Negative 57 and 49 is negative 8. And I take 7 times negative 8, which is negative 56. And 56 minus 56 is 0. And if you remember the last number, I put in a box because that's my remainder. So therefore, I started out my problem. I started out with x to the 3rd. Therefore, I go 1 power less. This is 1x squared plus 7x minus 8 is the answer to this divide problem with a remainder equal to 0. And that's how you do synthetic division. Now, very, very important note, which we're going to deal with a lot. If the remainder is equal to 0, that's going to be very important for us. That means that x minus 7 is a factor. It's a factor of our polynomial that we started with. So if the remainder is equal to 0, that means x minus 7 is a factor of that polynomial. It's going to be very, very important for solving polynomials when we go a couple sections later. All right. One more time. Your turn. Give this one a try. All right. First of all, I put my little box. Now I notice this is not in the form x minus a. It's x minus negative 3. Minus a negative is add. So therefore now my a value is negative 3. A equals negative 3. So that's my divisor. My coefficients, I have x to the 4th. That's the coefficient is 1. But the x to the 3rd is missing, so I put a 0. X to the 2nd is also missing. I put another 0. X to the first coefficient is negative 5, and then my constant term is 10. So I draw my line. Bring down my first number. I'm going to go a little quicker. We times. Negative 3 times 1 is negative 3. Add them together, you get negative 3. Negative 3 times negative 3 is 9. Add them together, I get 9. Negative 3 times 9 is negative 27. I add those, I get negative 32. and then I times negative 3 times negative 32, which gives me positive 96. And when I add those together, I get a remainder of 106. Sometimes they get really large. Therefore, I started with x to the fourth. That means that's the coefficient for x to the third. This is the coefficient for x squared. This is the coefficient for the x term. And then my constant term is minus 32 with a remainder equal to 106. And that's how you do synthetic division. If you have further questions, please talk about it. All right, the last thing that we need to talk about is called the remainder theorem, and it deals with synthetic division, what we just talked about. What I wrote in green is the remainder theorem. If you have any polynomial, we'll call it capital P of x, like we were just doing, and you divide it by some binomial x minus a, like we were just doing, then whatever your remainder is, whatever you get for r, is actually the value of your polynomial if you plug in a into the polynomial. Now, I did one problem already for you. X to the third minus 4x squared plus 5x plus 1, and we divided by x minus 3. So our a value is equal to 3. And I actually worked it out for you. And if you notice, I've got a remainder that's equal to 7. What the remainder theorem says, if you want to evaluate your function for your a value, for x is 3, if you do synthetic division, the remainder is the answer. So the value of my polynomial, if I put 3 in for x, my answer is going to be 7. So that's my x value, and that would be my y value if I wanted to plot it on a graph. Now I can prove it to you. If I take the number 3 and put it in for x, I get 3 to the third minus 4 times 3 squared plus 5 times 3 plus 1. Well, 3 cubed is 27. 3 squared is 9 times 4 is negative 36. Plus 5 times 3 is 15 plus 1. Well, this is negative 9 plus 15 makes positive 6 plus 1 makes positive 7. And it checks. It does exactly what we said. So when you put a number, if you took that number, if you want to know the answer what y is, take that number, do synthetic division, and the answer will be the remainder. And that's what the remainder theorem says.